Applications of exponential notation. Let's review. If n is a positive even number, then negative 55, in parentheses raised to the n, is also a positive number. So remember, if the exponent is even, the value will be positive. So if n is a positive odd number, then negative 55 to the n is going to be a negative number. If your exponent is odd, your answer will be negative. You have an odd amount of negatives that you're multiplying, which is going to give you a negative result. So pause the tape and go ahead and read question number 1. So I'm going to just start talking about it. So pause it and read. When you're done, start it again. So how much mold has she started with? The area, 22 centimeters squared. And then it says that the mold quadruples. Okay, so that word quadruples means multiplied by 4. So times 4. Every 24 hours, so every day. So how much mold is on that bread on Tuesday? That's when it starts. So that's when she started to look at it on Tuesday. So the area is 2. And if it quadruples, so it's multiplied by 4, you end up with 2 times 4, which is 8. And it continues to quadruple each day, 8 times 4, which is 32. And then, again, quadruples, 32 times 4, 128. Okay. So by Friday, the square centimeters on her piece of bread was 128 square centimeters. That piece of bread was probably pretty moldy. So what did she start out with? Her initial value was 2. What was she multiplying by? She was multiplying by 4. And then Mary should expect to see 128 centimeters squared of mold. Okay? So we put that in sentence. Mary should expect, can't seem to make my E there with my stylus, Mary should see, there we go, 128 centimeters squared. Okay, pause it again, read number 2. 2 is going to look a little bit different. I'm going to just start talking about it. So he puts in $350 into his bank account. 4% interest. Notice I'm circling the important information. How much will be in his account at the end of 10 years? So there's our time. So we've described all of those pieces, and we have a nice little formula that's going to help us to find out how much he's going to have in his bank account after 10 years. So A equals, that's starting amount, P, $350, times 1 plus. Now, the key is with that 4% interest, that's as a percent. So 4% in terms of a decimal is 0.04. That's what the formula wants. 0.04. And then raised to the t. That's going to be our time. So going to your calculator to do that calculation, to find out after 10 years, okay, Jonathan is going to have $518.09. Okay. Go ahead, flip the page. Take a minute, pause it, and read this question. So I'm just going to start talking about it. We're going to fill in that table. Okay. So we've got a secret. says the next day you tell 2 other friends the secret. The day after that, each of them tells 2 other friends. If this pattern continues, how many people will know the secret in a week's time? So on day 1, okay, how many people know the secret? 2 people, you and your best friend. Okay? And then tell 2 more people. Okay, the day after that, each of them tells 2 other friends the secret. So we're multiplying by 2. So now we've got 4 people know the secret. Multiplying by 2, 8, 16, 32, 64. We keep multiplying by 2. So at the 7th day, 128 people know the secret. So now I've added another line here in our table to talk about exponential form. So initially, how many people knew the secret? The initial is just one person. She, your BFF, she's the one who knew the secret. So just one person knew the secret. And then what were we multiplying by? We were multiplying by 2. So our base, our multiplying value is 2. Okay? So our days are our exponents. So if I start off and I say, okay, one person was my initial times, and then we doubled it, 2 to the first. And again, we continue with that exponential form. How many people initially knew it? 1, okay, times 2, and then the day to the second. So if you think about what 1 times 2 to the second, that means 1 times 4, which is 4. Day 3, how many people knew it? To start with, 1 times, now 2, how many days have gone by? To the third power. 2 to the third is 8. 1 times 2 to the fourth power. Sorry about that. Shift a little bit. So 1 times 2 to the fourth. 2 to the fourth is 16. 1 times 2 to the fifth. You're starting to see a pattern. 1 times 2 to the sixth. 1 times 2 to the seventh. So now we have 128 people know the secret. Okay. So again, our base is 2, and our exponent is the number of days. All right, pause it, read it. Got another one dealing with depositing some money into the bank. So how much will we start out with? $3,000. 1 plus, again, that rate is 5%. 5% as a decimal is 0.05. 0.05. And how many years, okay, how much will this account, how much will be in her account when she retires at 65? So if she's 65 years old when she retires, and she put this money in at 30, how many years have passed? 35 years. So after 35 years, she's got $16,548 in that account. Okay, all of that can be done with your calculator. Go ahead and flip the page. Okay. So we pause it, read it. We're going to start out with, okay, how many do we start with? We start with 50 bacteria. Okay. And it says, let's look for what our multiplier is, doubling. So we're multiplying by 2. And they want to know after 5 hours. So 1 hour, 2, 3 hours, 4, 5 hours. So if we're doubling, we start out with 50. What's 50 times 2? That's 100. Okay. And then 100 times 2. 200. Oops. Sorry guys, got this moving all over the place here. There we go. Times 2 again. 400. Start to see the pattern, times 2 again, because we're doubling every hour. 800. Now this is growth of bacteria. That's, I don't know, in my mind, that's kind of gross. 1600. So let's talk about what this means. So our initial amount, what do we start with? We started with 50 bacteria. And what are we multiplying by? We're multiplying by 2. That's our base. And then what was our exponent? Our exponent is the number of hours. Okay, so if we talk about this as our exponential notation, okay, we've got some interesting stuff here. So this first one was 50 times 2 to the first. The second one was 50 times 2 to the second. It's always that initial amount, 50 times 2 to the third, 50 times 2 to the fourth, and 50 times 2 to the fifth. Go ahead, pause it, and read about Kevin and how he went to the movies. So he told 4 friends about the movies, and those friends told 4 more friends. How many people are going to know about the movie on Friday? So filling in our chart, along the top we've got the days of the week. Number of people. Okay, we start out with 4 people. And they're telling 4 more people. So our multiplier is 4. So we have 16. 16 times 4 is 64. Times 4 again, and we're at 256. Times 4, 1024. So our initial value, let's talk a little bit here. Our initial value was 1 person, Kevin. And then what was the multiplier? Our base was 4. Our exponent, okay, is the number of days. So let's go to our exponential form. So what was our initial value? Kevin times the multiplier. 4, day what? Day 1. And the next one, our initial value, Kevin, 4, how many days? 2. 1 times the multiplier, how many days have passed? 3. 1 times 4 to the 4th. 1 times 4 to the 5th. You can go ahead and read 7. I'm just going to give you the answer on that one. We've done a few of them already. I'm going to tell you what the answer is. If you've got some questions, by all means, ask me in class. And the last one. Okay, take a second and read it. And we're going to set up our own table because it's not here for us. So I'm going to draw a nice long table. Trevor's folding paper. Okay, so we've got the number of folds. Let's do an exponential form. And then the size. So number of folds. How many times he's going to fold this paper? The exponential form, and then the size of the paper. So now this changes it up a little bit. It's talking about how many times did he fold the original. Okay, he ends up with a folded paper which is 1/64th the original size. Trevor is folding a piece of paper in half. In half. Right? So if we have 1 fold, okay, that's 1/2 to the first power. I'm going to put that in parentheses. Got a fraction there. Okay. So in the size, 1/2 the original size. All right, now if I have 2 folds, so now I should say our initial amount was one piece of paper. So we have 1 times 1/2, there's our multiplier, to the second. We'll get down to the size in a minute. Let's keep going with our exponential. So at 3 folds, our initial was 1 piece of paper, our multiplier was 1/2, 3 to the 3rd power. 4 folds. We're going to do some calculating here in a minute. To the 4th. So using your calculator to calculate 1 times 1/2 to the 2nd power, that's going to be, whoops, let's see if I can undo, that just moved around on me. Sorry about that. I'm going to go back a little bit. Okay, so that's 1/4, and then we have 1/8. Hopefully you're starting to see a pattern here. Let's go back up here to the 4th, and that's going to be 1/16 because we keep multiplying by 1/2. We want to get to 1/64. So at 5, 1/2 to the 5th, that gives me 1/32. Maybe one more time. If we multiply 1/32 by 1/2, bingo, winner, winner, chicken dinner. 6 folds. So that is 1 times 1/2 to the 6th. How many times did he have to fold his original? 6 times.